Welcome to Ask and Learn.
All right, so the first thing to note is that when x is greater than 0, we have that log of n is going to be less than the square root of n. Right, and so now we're wondering which of these functions is going to be use fewer operations, right? So we're looking at let f of n, say, be n log n. And g of n be our second algorithm, n to the power of 3/2. Okay, well, when k is greater than 1, we have that log n must be greater than 0. So we're going to let k equal 1, and therefore use n greater than 1. Of course, you could use a different value of k, and you'd end up with slightly different results here. But this means that f of n being equal to the absolute value of n times log n. And since this must be positive, this is just going to be equal to n times log n without the absolute values. Is going to be less than n times the square root of n. And so I got that from this property that I stated at the beginning of the video, that log of n is less than or equal to square root n. Okay, but n times the square root of n is precisely equal to n to the 3/2, right? Which, again, since n is positive, must be equal to the absolute value of n to the 3/2. Okay, so that tells us that n log of n is going to be less than this n to the 3/2, right? So by definition of big O notation, f of n is big O n to the 3/2 when k equals 1 and c equals 1. And this implies that as n grows, n log n grows slower than n to the 3/2. Okay, so therefore the algorithm with fewer operations is f of n, the log n log n here.